All right. Welcome back to the meeting today. And I apologize for being late because I gotta find out some issue. Like some of you skip some questions on the second exam. It's basically almost impossible for me to grade. So I need to know what's going on. Like we have um 3 hours of the exam time. So what's going on? Why we skip so many questions, or maybe um, there are some issues going on. So I need someone to have that issues email me so that we can work them out on that reason. So uh,
Professor, did you get my email back?
I actually got your email. So this is very special. Okay, I'm gonna answer your email after that.
Okay.
It's not about. I actually saw your file, but it's just the question they do not match. So making sure that you're gonna use the same question that matches the question that we have on the test. So you know. Anyhow, again, that if you miss more than 5 questions, you need to email me so that we can set up some makeup question for that part. And
Okay.
so it's that can help you get back some points along the
Yeah,
way.
because I added a picture to that email.
Yeah, so I saw the picture for that, and I actually saw the file that you uploaded. But the thing was, we missed questions, maybe 1 or 2 questions, not a big deal. But
Okay.
yes,
Okay.
you are not a big deal. But I concerned about this. Some people in this class that we missed so many questions. I would say more than 6 questions, so that's gonna be a big deal. And
Oh, okay. Okay.
yeah, so either people don't know how to do them, or maybe it's just too hard for that part. So we're gonna, yeah, that's you. So we're gonna work them out. Yes. So yeah, I again that we need to finish the exam. If you start for like I don't really have enough time to finish it. It could take a little longer for that to do them. So you don't really have to like submit the exam exactly the same time that we have. So make sure that we submit all 20 questions with the answers and the things. So I mean the work is I only grade the exam through the work. So you don't see the grade on test two, and you only see the grade submit work on test years. This is the thing that I took out in the second exam grade. And make sure that we submit the project for tonight, I believe. So that will be due around 11:59 p.m. So that basically the end of the day. Um, so if you don't know how to get the data set, you can email me. I'll show you how to do so. And I got one email saying they don't know how to copy the data set. You just drag down the arrow. So you see the plus sign on the corner of the arrow. You drag them down. And this is how we copy the same functions corresponding to each step that we made. So that's pretty much the chapter 5, 6, 7 project about, and now we're heading to chapter 8 and 9. Okay, so right after we finish chapter 9, and did I upload a project yet? I think I did. Right?
What do you mean by like Project 3?
Project
What do you
3.
mean?
Yeah.
No, I didn't see
I
Project 3.
didn't see a Project 3, yeah.
Oh, you didn't see the Project 3, so let me check them out real quick. I don't want.
Yeah,
I
I
mean,
haven't seen it either.
if
Okay.
you did it today,
I'm sorry.
if you posted it today, I don't know. I didn't. I'm saying like yesterday, I didn't see a Project 3.
Okay. So that might be a problem. Um, let me just check them and let you know what it is. Okay. So the project. Oh, I haven't uploaded it. I actually have the project available. Let me just. I forgot what it is. So the upload should be relatively short for that part. So let's say project 3. Let me just go to project 3. So this is what we have right there, and I forgot to upload it. Just to be completely honest. So the reason why I did not upload it because it's only two-part. Okay, it's very straightforward that we're gonna deal with that. So I really want you guys to do well in this part. And did you guys see them? I don't see the message right here. Okay, so let me share. I'm late. Can we make up questions? No, you missed 2 questions that you can't make up. No, so at least you miss at least 5 questions, and we're gonna make up some points, but not at all. Maybe at most 10 points on the exams, 10 depending on the weight of that. Yeah, but generally this is happening when we have some, traumatizing situations going on in New York City, and everybody knows. So if you miss maybe 2 questions, and I can't let you make that up unless you miss more than 5 questions, then I would consider that option. So anyhow, so this is what we have for the final project. So how we're going to use the megastat and Excel to find the linear regressions. And it's simple. You can just finish it in around 2 or 3 minutes for that, but we need to answer a certain questions that based upon that. So this is going to be the chapter 15 that we'll be covering on May. Will be pretty much the last lecture. And of course, the second part was we're going to run the hypothesis test. This is what we're going to be learning next week. And so this is going to be 4% of the grade. So the total for the project will be 3, 3, and 4. But these questions are 4%. So each question going to be 2% of that. So usually the later work going to count more points toward the semester, and this is what's happening. Concerning the final exam, when we going to have the final? So the final exam, anyone know the final exam schedule? Should it be
Didn't you say May 15th?
May 14, right? Is it?
Oh, 14th?
Yeah. So the calendar tells me that the May 14 will be the last day for the spring semester, and there's no way that I postpone the final exam on May 14. So this is the day that you're gonna take the final exam together, I believe. All right.
Oh, so we have to take it on the 14th.
You have to, yeah. You have to take it on the 14 for that reason. Up to Friday 15. Yeah. So we have a 1 day period.
Oh yeah, that's what I meant. Yeah.
Yeah. You have 1 day period from 6 p.m. to 6 p.m. of May 15. So after that, we're not going to see each other again in Zooms, and either I congratulate you to pass the class, or I don't know. So, and hopefully I want to pass all of you at the end of semester. And this is what's so important for us is the situations in New York City. Okay, so by the time that we have from May 14, we still have 1 month left, correct? But we so we're heading to chapter 8. We finished chapter 8. Let me just tell you the plan that we're going to do. Okay.
Wait, when is chapter 3 due?
I'm sorry.
Project.
What is
When is project part 3 due?
that? Basically, do the same day on
On the 14th?
maybe I can
Okay.
make it up to May 16.
Okay.
Right. So we can have more time to focus on the exam before we work on a project. But I mean, the earliest submissions counts. Some people submitted the project on May 10th or maybe May
Right.
12. I don't know. I mean, because the last project was literally a given points, I believe. It's just something that we need to go around with that part.
Do you
Okay.
think we'll have time to have like a single class just for the project, like if we have questions?
Usually no. Usually I will spend at most around 30 minutes to do project 3. If we understand the concept and what it sounds like, it's just do it in. I'm gonna shoot out the sample project, and on Blackboard you can check them for that reason, and then you can just based upon that to work through it. Okay, so
Okay.
the project part 2, I cannot send out the sample project. It's basically the same question that we did, and but the part 3, we're going to I'm gonna send out a sample. It's usually like a few words, and I can tell you what it is. It's just based upon that, and you can get it done in around an hour or less. I'm not sure. Some people struggle with the SL project for an hour. Some people can finish it in 5 minutes. I don't know. I don't know what type. And finally, that we're gonna have the quiz. Somebody mentioned me. Somebody mentioned that there will be a quiz for today. So the answer is no. The quiz will be right after we finish chapter 8. So the quiz should be on Tuesday. Okay, on Tuesday will be a small quiz. So what is the quiz about? The quiz will be on today material. Okay, will be the very crucial material that we go to learn today. Okay. So again, that how we're gonna do the quiz? There will be 2 more quiz left on this folder, but I'm planning out to give makeup quiz. So let's say we have one quiz that did not go really well. So I'm gonna give you guys quiz number 6, just to replace the grade that you just replace the lowest grade that you have for the total quizzes that we took. Okay, so I feel like that's gonna be a little bit fair enough. So quiz 6 and 7. Okay, that'll be 2 more quizzes that we have right here. And after that, we're going to have a classwork. Remember that classwork would be the homework questions. So that'll be 5% of your grade as well. So if you underestimate the work that we have done, then you're wrong, because we have a lot of things going on with this. And some people haven't really submitted anything yet. So I wait until I grade it. So if you have anything that you need to submit, please do. So that, because you hold a grade back from the other people. So I'm going to grade them and then let you know the grade as well, and submit as much as you have. And so this is pretty much the thing. Okay, so so the classwork 11 and 12 should be done. And after that, I will
Sorry,
go to,
in regards to classwork 12, is it not? I thought the last day was like Sunday.
I'm sorry, the submission.
To submit classwork 12. I thought it was like to submit on Sunday.
Let me just check them real quick.
Or did you apply a date to it?
Did I apply
I
dates?
think I think he said Sunday.
I thought you said the end of the week.
I
Yeah,
you said
I heard end
Sunday.
of the week. Yeah.
Oh, really? Yeah. So let me check the date real quick for that. I didn't put down the due date for that though.
I know
Yeah.
you said like by Sunday we should
Yeah,
have it.
by
posted.
Sunday we should have it, and so but I did not put down the due date.
Okay,
so
okay.
making
I was
sure-
just making sure. Yeah.
the reason why I want people to submit the work on Sunday, so I can get the grade for the people, right, who basically long for it. So basically, this is the PDF file, right? You can literally download it and do it. Just write the work and submit them. Take a picture, send an email yourself, whatever you want, and submit on Blackboard. And should be very straightforward. And try not to hold back from it. I know we have some personal issues, some technical issues, but please try to work to get it done by Sunday. And so this is based upon the 2-day lecture that we have, and relatively not new to us. But after the classwork again, we going to have a quiz number 4. Okay, quiz number 4. I'm basically going to post all the quizzes right here. 4, 5, 6, 7 will be on each topic. Okay, so but the 6 and 7 are optional, and some people don't want to take 6 and 7 usually. The reason behind that was I'm happy with my grade. I don't want to suffer from doing all the work that you have. Literally, some people told me that they can forget everything after the final exam May 14th. That's fair enough. So this is the thing that I don't want to traumatize you guys. Anyhow, and today we're gonna continue on chapter 8. Any question before that? So again, the chapter 8. This is not gonna be the main core of the chapter, because what we have done is basically on the z-statistics. So the reason why z-statistics is impractical because of the fact that this is the normal model. So the normal model is usually a fixed model. So when it comes to the fixed model, it's not fun, right? We don't want to play around with something with a fixed number. Okay, so the reason why we're doing that one, because we need to know the population standard deviation. Or when we're dealing with a really, really big sample. Okay, so when it comes to like a very small sample, instead of having like 50 Bostonians, you might have maybe 10 of them, maybe 5 of them, maybe 6 of them, maybe 7 of them. So what's going on for all of this, right? So since if we don't know anything about populations, or that we're dealing with a small sample, so this is the distributions that came up, came up with in 1918. Okay, back in the day, where an Englishman who took the class of statistics, I think he never took a class in statistics anyway, but he took a class and he published in the newspapers back in the day where people usually use for the z-score. But he claimed that this model is basically not sufficient, not good enough, basically not good enough, not sufficient, not good enough to measure the confidence interval by itself. So he came up with his own model. So that's the reason why we call this is called the student t distribution. So I'm not going to write down the entire equation for that, the entire probability density function for that. It based upon the sample size. So it's normal curve. It's basically the normal curve. So what's going on for that part is, so we have, this is what we call the models, right? So the first model that we have will be called the Z model, okay? The normal distributions we call the grandparent model, okay? So grandparent, whatever you want to call it. So this is the Z distribution. This is the model that people use a lot before that. The Poisson actually believed that this model works really well as well until he found that this is actually not so good. Yeah, so it's all about the belief, and then sort of like, well, I have the best model ever. But now when it comes to practice, it's actually not going to be like good enough to measure such a small sample within a big population. So it turns out that he came up with this model we call a grandparents model. So what is model about? So all of this like T, so this is what we call the grandchildren T student T test. Okay. So it sounds like I'm doing some genetic thing, but it's actually not. This is what we call the grandchildren. Okay, all of that. So we're gonna put it down here. And so this is what we call the student T distribution. Okay. So it's not about like this one is better. It's just back in the day where we haven't really had enough tool and have enough research for that. So we misbelieve that, well, the Z is actually really good until the T distribution that came up with. So so what's so special about this is how the same characteristics at his grandparents, that it is normal curve. There's no doubt that we can say that this is not true. It's have to be true. In fact, this is what we call is whole normality characteristics. Okay. Characteristics. So if somebody told me whether or not the student T distribution is normal, it's absolutely normal. It's basically normal. So we can check that the curve that we have right there. So this is what we call the student T distribution. And what it looks like is that, well, I mean, it's basically normal. You can check them, but it's varies. It's different depending on how big of the sample size that we put down. So let's say we put down the sample size equal to 3, meaning that the V will be called the degree of freedom. Okay, so it has some degree of freedom. The degree of freedom is basically changing the curve, right? So it's not going to be like a fixed curve we have right there. So this is what we call a fixed distributions. So this distribution will not change over time. So this one's always fixed, okay? And this one is different, right? Vary distributions. So each time that you put out and you put in a new n, and it's gonna generate a new function for us, a new probability density function for us. So I would say this is a so it depends on, so the model depends on sample size, okay? So how big of that depend on what we're trying to insert to. So when we have like a small sample size, so which is called degree of freedom, okay? And so what we have, df equal to n minus 1, only for this chapter. Okay, only for this chapter. It's not true for all the model that we study. Nowadays we have like 1,000 models. So depending on the need of the statistic is where it converges to. Okay, if you ask me how many true models that we have for the grandchildren, it can be like 10,000 models, but they basically generate the same thing. But it's just different depending on how big of the n will be, okay? So let's say the n equal to 5, they're gonna give you a different model. The n equal to 6 is gonna give you a slightly different model as well. So it depends on the degree of freedom. Okay, so, and then the last characteristics is basically the most important thing. For those of you who want to take a high level, upper level statistics, this is what you need to know, is that no matter what you do, the grandchildren, again, is always converges to the Z model. This is what we might need to know, okay? So this one always converges, okay, to the Z model, to the fixed, to the grandpa models, to the grandpa models. Okay, so very important to the Z model. Yeah. So if you don't study high level, you just stop the lecture right there, and you don't really have to care much about that. But the T is a very powerful model. It's hold the same characteristics of the grandparent. It's actually converging to it. Okay, and so it's more like an updated version of that. And so as it turns out, when you see that when the degree of freedom, when the samples actually go to infinity, when what it looks like is completely become a normal curve. So what's so special about this part is that when we have like a small sample, let's say we only have 3 samples, meaning that we're dealing with n equal to 3. So what's going on for that is the degree of freedom will be equal to 2. Okay, so the degree of freedom determined by the samples minus 1. So the number of samples, we have 3 of them. We take away 1, we get 2. So if we want to look at the T distribution, so let me just go to table. Oops. So this is what we have for the T distribution. Okay, so this is what we need to use on the T model, and absolutely that's going to be on the exam. There's no way that we can skip them. So the first, the column that we have right there, we call the degree of freedom. Okay, we call it the degree of freedom, and this row will be the confidence level. So we can basically check that the UC is confident. If you ask me why the UC, well, it's easy, the confidence. Okay, so this is 50%, 75%, 80%, 85%, 90%, 95%, 98, 99, and 99.9. Usually the statistician never take up to like 99.9%. That is too accurate, right? I mean, it's better to be more confident. It's better to be more certain of what we're doing, but necessarily we have to take into account a certain factor, a certain error bound. Sometimes if you want to become a little more certain for that, but you know, the bound that we generate is not good enough. It doesn't really good enough to tell us anything of statistics. Because the bigger the confidence, the bigger the bow, right? So let's say if I generated the model that telling me the final exam average basically bounded between 30 points up to 100 points. This basically useless information that you want to that we don't want you to look at. So in fact, the recommendation would be 95%. I mean, 90% is pretty good as well, meaning that we have 10% chance that the report will be wrong. I mean, we would have 10% chance that it's going to go wrong for that part. And so what's going on about this part is when we look at the degree of freedom. So let's say I take the degree of freedom equal to 2. At 99%, you can see that the score is actually really big, right? So that would be 9.925. If we look at the z-score at 99%, right? So that'd be 2.58. This is the fixed value. It's never changed over time. I don't really care how many aims, how many sample that you give. This number is always fixed. For 95% is fixed, would be 1.96. But for the T model, it's changing differently depending on how many samples that you put into the model, into the investigation for that. So let's say we increase the degree of freedom. Let's say you draw out more sample. From the population, let's say I take 9 of them. So meaning that I have to look at the degree of freedom equal to 8 because the degree of freedom equal to n-1 compared to that part. So, and now when we look at the A at 99%, that we can see that the score dropping, right? So to 3.355, right? So we know the fact that the error bound that we learned from chapter 8.1 would be the following thing. So we know the fact that the E equal to the Z times the standard deviation over radical N. Okay. Right? So this is what we call the error bound. But in this part of the thing that we don't know the population standard deviation, remember, when we need to compute the standard deviation or when we from a sample, so this is where we have to do the Z, the T. Okay, so in other words, we're gonna change that to this the big choppy O into the small s, which is called snack. The snack have to go with the T, so that's gonna fix them. So what we need to be doing is that the standard deviation will not know, right? So this one will not know. So for example, that we don't know what it is. So this is a no. It's not given. When the population standard deviation is not given, then we cannot use these forms. Okay, so we cannot use these forms for that part for sure, 100%. Okay, so now we're gonna go back. We have to deal with the error bound using the T distributions based upon the sample standard deviations. Okay, so this is what we call the sample standard deviations. And this one is definitely gonna be something that we can compute it. So this is what we call sample and standard deviation. Okay, usually on the exam that we need to compute this this problem, this score with the mean as well. And after that, we do the same thing. So we're gonna set up the bell for the population mean, basically the same things as we did earlier. So that would be the X bar minus the error and X bar, we add the error. Okay, so I don't mind if you do it or you break it down to 2 steps, or you can just combine them to one single step. So the step that we're going to set up would be or. I'm going to put them there or, so that we can check what it is. Okay. Or what we need to do is we're going to take X bar plus and minus T times S over radical N. That's basically the thing that we need to do. Okay, it looks abstract.
Sorry.
Yeah.
Is it so? It's T times S over N, or is it T
Radical
times
N.
S all over N, or radical
Over
N?
radical N? Yeah. So this is the error bound. If you don't want to separate them, you can do it at once. I feel like that's going to be a little easier than you separate them in terms of 2 part. But either way, it should be able to give you the same answer for that part.
Oh, so it wouldn't matter anyways, even if
Yeah.
it was okay.
So the error bound, remember that the error bound depends on the t-score, right? So if the t-score is big, the error bound is big. if the n is big, the error bar is small. So it's more like what can I say? It's more like a trade-off between bands out, between the sample and error. So if you have more sample, let's say you increase the small sample up to like maybe 20, 20 sample, then we have to look at the degree of freedom equal to 19, and then we check at 99%, so that'd be 2.861, right? Which is decreasing. It starts decreasing. You can see that the score of the t-score always decreases. Why it decreasing? Because we get more information. What's going on for that? If we get more information, then the last characteristic hold. This t going to be convergent to the grandparent model, which is called the Z model. I mean the fixed distribution model. So, and then we can see that we can go all the way down. So we can, if we check all the way down, which is called infinity, right? So we can check it on your table that I gave out. When you go to infinity, what's happening? So at 99%, this is 2.576. It's actually the better point is when you look at 99% right there. So this is only two decimal number. That'd be 2.58, but the actual number is 2.576 or something like that. If I want to look at 98%, so that would be 2.326, that would be 2.33, pretty much like that. If we look at 95%, so this is what we have for the fixed model, because it's convergent. So this is the t, but when t go to infinity, when the sample size go to infinity, that's convergent to the Z model. So this is what we call the Z model. So you get 1.96, and we can also get 1.96 from here. That's pretty much a thing. If I go to 90%, go down, you're gonna get 1.645, will be pretty much the same thing as 90% of the Z model, that we got the same answers, which is 1.645. It's pretty much the same thing. So as a matter of fact, and this is the thing that we call the T, okay? So we're gonna utilize this until chapter 9, and that's pretty much it. The last table will be more important for chapter 11 and 12, and we're gonna talk through that later on. But generally from 8 and 9, and then we have to deal with that a lot, especially this and that, okay? So so the score that we found will be started to decreasing. So we can see that all the value here that basically converges. So we can see that 2.042 go all the way down and get 1.96. So this is basically the fixed point that you can't go any lower than that, because this is the grandparent model that we have right here. So this is all we need to do. So now let's take a look at a few examples and see how we're going to proceed that. So you can see the score start to decreasing when we have a big N. And so how can we convert that? How can we interpret that and construct it? So it's basically the same thing, that we take the X bar minus the T times S over radical N, and X bar plus T times S over radical N. This is the thing that we need to do. And this is what we have for the chart for the quantitative data set, where we first step, we calculate the E, and then after that, we compute the range for that. So by taking the X bar plus and minus the E. So now we're gonna go to one example and see how we can proceed to that. So now we're gonna make it a little bigger so we can see clear what's going on for that part, and we can work on it. All right. Okay, so I would call it, this is an example that we have from the notes on the summary. So what is the most important when we highlight them will be the X bar, right? And random sample, we have 36. This is the N. So we have a sample standard deviation. Remember, the sample standard deviation is given. So that'll be equal to 10. And we need to compute 99% confidence interval. This is what we need to do. Okay, so the first step, we better to write them down all information that we know. So, I mean, this is not necessary, but this is so important that we don't skip any number because we need to utilize all of them, right? So the first, X bar. The second, that will be the n. So the n that we can see that is equal to 36. So we put down 36. So when it comes to n equal to 36, and of course, then we're going to compute the degree of freedom. So the degree of freedom will be n minus 1. So because it's only for t. So 36 minus 1, so we can get 35 degree of freedom. So basically, after that, we're going to go to 35 on this column. So for the sample standard deviation, remember that we do the t-score because the question gives us SNAC, gives us the S. So the S in this case that we can check is equal to 10. This is a question that I took 20 years ago, I believe. Because if you tell me that you test only 85 messages, you're lying, right? You should test more than that, especially for girls. I'm just kidding, no bias. Anyway, so we have the confidence interval. In this case, will be 99%, okay? So I converted to 0.99. This is what we have to do. So very important, why do we have to convert to 0.99? Because we need to read the chart with the decimal points right there, so they can compute it along the way. So, so all we need to do is that we need to first compute the error bell. So the error bell would be equal to the t times the s over radical n. Okay, so this is a thing. Right. So what is the t? The t based upon two things. The one would be the confidence interval. The second one would be the degree of freedom. This is special. The z only use the confidence interval. That's it. But for the t-score that we have to look at the degree of freedom is what? Based upon two things. So the first that we have to go down to 35. The second that we have to look at 95% confidence, is it? Yeah, 99%, yeah. So I forgot a question. So 99% confidence interval. So I go down from 99% to 35. So I can see the answers, which is 2.724. Correct? So this is what we found on the t-score. That would be 2.724 on table number 4. So very important that we have to go down to table number 4, and then we figure this out. So that would be 2.724. Okay, so this is a thing. We multiply by the standard deviation. So the standard deviation that we see that from the question is 10. It's unchanged, right? And
sorry, you found 2.724 by going to the, could you go back to the chart really quickly? Sorry.
The chart that we have is, yeah, right here.
So it's because there was a, because you had to go to the 0.99 confidence interval and then go to 35.
Yeah,
okay,
that's
got it.
This is the thing, because they gives us, the question gives us 36 sample. If the question gives us 25, then you have to go to 24 degree of freedom.
Okay, got it.
Yeah.
Thank you.
So, so this is so special for the T because each sample going to give us a different score. So we gotta be really careful for that. And then we divide it by the radical 36. Remember, even if that we go down to degree of freedom equal to 35, but the n is actually not 35, the n still be 36. So this is a thing that people actually make some mistakes on it. And so we're gonna do 36 here. So after that, we're gonna compute this score. I believe I have on my own calculator. I don't need you guys anymore. Yeah. So you can give me a lot of headaches and a lot of heart attack when you compute it, and different people give me different answers. I believe everybody can download this calculator online, correct? I mean, you're gonna use it for the rest of the semester, but for those of you who taking continue to take math course, I'm not sure. Maybe you don't use them for the fall, but you might have to use them in the fall semester. I got 2 of them, which is really cool, but I got rid of 1. And so what we have to do is that we're going to take 2.724 times 10 divided by radical 36, correct? So the answer for that, you can see, you multiply them and then you divide, hit the second, and then you hit the square root. You can get, hit the second and x squared, you're gonna get the square root of 36. So the answer that we found is 4.54, okay? 4.54. I just put them down. So after that, we're gonna set up the barrel. So what we can do is the barrel would be x bar minus the e, and x bar we add the e. Just do the same thing over and over again. And x bar we add the error. Okay. So that being said, we just basically do 2 calculations 1 more times. So the first that we need to take, so the x bar still in use, right? So we have to use that x bar equal to 85. And I subtract 4.54. And then on the right, I take 85 plus 4.54. So we finish. So the math that we need to be responsible for, we take 85 minus 4.54. And after that, I take 85 plus 4.54. So the answer that we get is 80.46 and 89.54. That's pretty much it. Okay, so and so the answer for that would be 80.46 and 89.54. So that's pretty much it. Okay, we finished. That's it. So this is the final answer. So remember, the mean, meaning that I will be 95%, 99% confident at that time, not this time. I'm basically wrong right now. If I say, well, the average message that people text will be between 80 and 89, that doesn't make any sense when we text more than 1,000 messages per day. So at that time that I can claim at 99% certainty, 99% certainty that the population mean that on average that all high school girls, not only for 36 high school girls that we have. So the claim that we make have to be on the entire population. So I can tell you that all high school girls, they send around 81 to 90 messages per day, okay, daily. So this is what we can say. Anyhow, so that example is where we need to look for the z-score, the t-score. So the t-score can be found, remember, using table number 4. So I'm gonna put them down right here. So this is table 4. It's really important that we don't mess that up, this table, okay? So remember that the t have to be on table 4. And this, I mean, there'll be a question on it on the exam for sure. So we go down to 35 to the degree of freedom. And the confidence interval is 99%. So you're gonna go to 0.99, not 0.999. You only have 2.9. You ignore the last column because you never use that. I will 100% guarantee you that we usually don't use this number. 99.9% is really big. Percentage. It's basically not practical as well. So there's no way they can be like 99.9% certain. It's really hard for that part. So anyhow, so the score that we found, we're gonna take the joint between 35 and 0.99. We got 4.54. So that will be it. And that's pretty much the thing that we need to do, okay? So for the next example, I believe will be slightly different. So let's go through that. So another example, I would say, this one is basically harder, okay? But something hard, very likely to be on the exam. Okay, so what is this example here? So I would call this example 2. Okay, and I'm gonna box them. not high, not both of them, but anyhow. So now we're going to analyze this. The question doesn't give us X bar. The question doesn't give us anything. The question only gives the number of data set. That's it. So this is more practical because we need to compute a math, right? So let's say the question is going to gives us 6 employees, right? 6 people. Okay. So when we deal with a very small sample, of course we have to do the T. And the question also gives 95% confidence interval. Okay, this is what the questions gives us. And what we need to do is we're going to compute the X bar. So we need to compute the X bar because the question doesn't give us that.
Okay. I'm sorry, Professor. Why did you say that we have to get the DF?
The reason why we need to get the DF is because we have to deal with the T distributions for the unknown population standard deviations. In other words, if the question gives us the keyword sample standard deviation, then we definitely have to compute the DF when we look at the chart on table number 4. Or the question gives us like a following 6 employees like with different prices. So when we are dealing with a very small sample, then we have to use the grandchildren model, which is called a T model. So the question doesn't give us anything, so we need to compute these 2 things, right? Basically, right? So I believe that most of you can do so. And in fact, so the CI we have is 95%. Okay. So the N is 6, right? So we have 6 people, and I'm sick of this question. Now we're going to do the DF. In this case, would be equal to 5. How can I compute the mean and standard deviations? Do we still remember how to do so? Do we still remember how to compute the mean and standard deviations?
Yeah.
Okay. You just what?
For the mean, you just count them and then divide them by how many numbers, and then the standard deviation, you need to subtract the number from the mean.
Square and
yeah,
add
and
them
then
up.
square it and then do all that stuff.
Yeah, and divide by n minus 1. So a lot of you might be asking me why we divide by n minus 1 because of that, because of the degree of freedom of the t-score. The sample standard deviation is actually coming from the t distribution when we're dealing with a small sample. So the t is designed to deal with a sample, okay, the sample thing. So when we deal with that. And so the degree of freedom is n minus 1 and so on and so forth. So we can have the problem right here, right? And I think I wrote out a solution. And so so I'm not gonna do all of them. So I'm gonna do it on Excel, to be completely honest. We're not gonna do it hand by hand. That's basically too much, right? I mean, you can do so, but we have the Excel, so why don't we use it? And again, that I don't use Excel very often, so I apologize. Sometimes the thing's going very slow. So what we have here, we have 180, 260, 60, 40, 180. 260 and 60, 40, 60, 40, and 180. So all we need to do, just look for the average for all of that. So the answers is 120. So that's have to be correct. So the value that I computed was correct. Of course, I computed this question so many times. And so the standard deviation, I can do STDV for sample, and I can drag them down for all of that. So I got the answers, which is 83.9. And this is also correct. so you can check them out. I mean, if you ask me how many website can we check, there's a lot of them. So you can, I mean, people can actually. I know some of you actually know how to compute it, so that's the reason why I asked you to show the work on the third exam, using the stat. You can see that there's a lot of calculations, and so there are actually a lot of things that we can do as well. But if you do them without showing work, you don't get point for that. Remember, so you can justify that using the things that we have here, and so on and so forth. And there's also the variance, the table for this part. I think you can do that as well, statistics. And so this is, I believe this is what we usually do on a calculator, right? And so, but we don't have to use that. It's just too much stuff. If we can do, you can just literally go to compute the sample standard deviation, right? You can check it. And there are a lot of websites to help us do so. Math is fun, right? Math is not fun. Math is even harder than my life. Okay, so we're gonna put them down as 180, 260, and 60, 40, and
100, and then 80.
Right, and then we do the sample, and you can see that the answers that came up with was the mean is 120, and the standard deviations is 83.9. But on the exam, you still have to put in down the things when we compute the standard deviation and the mean, or maybe you have to make a chart for that. So the first step will be the number, the second step is average, and so on and so forth, right? Or you can do something like that. So we divide it by 6 minus 1 because this is a sample standard deviation. So we get the answer, which is 83.9, and that is fair enough. So, and that's pretty much the thing that we need to do. So I'm gonna copy this and post it right there. So I'm gonna copy this part and use it as the questions and post this here. Okay, so this is what we call the average. And I do the same thing for this part. I copy this. I have the standard deviation done. Right. I mean, there's a lot of websites that you can use, not only for one, but there are so many of them, to be completely honest. Right. Okay, so that's pretty much a thing that we need to do. And after that, after we get the X bar, after we get the sample standard deviation, then we need to do what? We need to compute the error. So if you want to shortcut them, right? So you can just take X bar plus and minus the error, plus and minus T times S over radical N. So this is what usually people do in intermediate statistics. So I can take X bar plus and minus T times S over radical N. I think this is what it did.
Quick question. So
Yeah.
the mean, just to double check, the mean can also be considered the expected value, right?
Yes.
I got it.
Those two different things, but it's close. The concept is correct, but
but this is standard error, right?
Yeah. So this is what.
Sorry, okay.
The standard error is this one, is S over radical N. But what I'm saying, the expected value is something that we don't know for certain. Okay, so the expected value is something that we when we do them is based upon a probability concept. But the average or the mean is based upon a data set, right? So we knew it already. The expected value is the average that we expect that will happen. Okay, so it's literally two different stories, but in terms of the calculation, that's pretty much the same thing. The concept is not the same. Anyhow, and so after that, so we look for the t-score. So the t-score is based upon the degree of freedom equal to 5, and the confidence interval is 0.95. Remember that you need to use this chart because I know some of you actually, I'm not sure what happening, but on the second exam, I noticed that people do the z-score with like 6 decimal number. I know that you're using a software, somebody help you out. So you have to use a chart in order to get the answers correctly. Okay, so you got to be really careful for that. So when I look at the 5 degree of freedom and 95 confidence interval, and I can see that the answer will be 2.571. Okay, 2.571. Yeah, 2.571. You can literally check on this chart, right? So you can see that it is 2.571. You go to degree of freedom equal to 5 and 0.95, which is right there. So after we get this, and we can just take the X bar is 120, right? I mean, you can break this down. You can just compute the error, which is something that we just did right here, equal to the t times s over radical n. It's up to you, but I can combine them. So plus and minus. I don't want you to write too much. I'm so tired, you know, I can't write that much on the board like that. Okay, anyhow, and so we're gonna take 2.571, correct? This is what we have found on the chart. And then we multiply by the sample standard deviations, which is 83.9. This is what we just did. And then we divide it by radical n. So in this case is radical 6 because we're given by 6 employee. And so all we need to do, I'm going to do the calculator for that. I'm going to take 120. I mean, you can compute this one first. So 2.571 times 83.9 and divided by radicand of 6 because we have 6 employees. The n equal to 6. I got 88.06, right? So meaning that I'm going to rewrite this as 120 plus and minus 88.06. Okay, so and then now we set up the bow finally. So the bow that we have is for the mean. And so we just do the math for that part. You're gonna take 120 minus 88.06. So that should be about between 31.94. And on the right, that should be add them up, right? So I take 120 plus 88.06. I got the answer is 208.006. And we're done, right? But this number doesn't really mean, doesn't really tell you anything because we have a really big standard deviation, right? So we have a big standard deviation with a very small sample size. What's happening? The error bar that we generated, that is even bigger than the standard deviation. That is unreal. That is really big. So 88.06 is basically close to the mean. So the answer that we found would be, so the people who spend on average between $32 and $208. I mean, you don't know that much information. You know how much they spend on money. Do they spend 100, 200? We don't know, right? But we definitely know that we spend less than $209, but more than $32. So this is the old information that we know. But if you ask me, hey, what is the actual value? What is the employee? What is the average that people spend on the large corporations? We don't know yet, right? So it can be $32, can be $33, it can be $100, it can be $200, but definitely going to be less than 208 and more than $32 at 95% confidence. Okay, so this is all it tells. But so again, this information just basically what you do. This is what we need to do. Some of you, if you ever heard of like a bootstrap, right? All the Monte Carlo simulations, all of that, right? So this is how they build up the confidence in the. They're not going to just do it one time. That's it. So we only just collect 6 sample, and then you told me that this is the result that you get. The answer is absolutely not correct. So you have to do it over and over again. You might have to collect 6 employees 1,000 times. Okay, for example, I want to prove this is correct, right? And so I do this calculation, this math like 1,000 times. And if I compute that the bow is relatively between 32 hours and 208 hours, we good to go. Okay, this is the actual range for that part. If we collect like 6 employees and do it 1,000 times, and each time they give you different answers or different value for the mean, meaning that this cannot be reliable. Okay, so so this is what we really need to pay attention. So this is how people deal with statistics. In order to get to the pattern, in order to get to the result, and that we usually have to do so many times, so many times, because this is called the empirical method. Empirical method. So, okay, so I saw some chat here. Did I change you the answers?
I thought it was. Oh, never mind. No. Sorry, you just rewrote it. Then I thought I heard it as 0.96. Never mind.
Oh, okay. So it's no. I have a calculator. The number never lies, so it's 88.06, and that's pretty much it. So we finished chapter part 8, part 1. Now we're gonna deal with the confidence interval for the population proportions. This is for the quantitative data sets. That's pretty much the same thing, because we know the fact that for the qualitative data, it is converges, right? It's basically coming from the binomial perspective, where we have the big chart, the big circle, and now we're going to have a small jungle for that part, and a smaller sample from the big jungle. And we can also say that this is a population n, and this is small n, and then we just drag a few sample and drag a few guys here, and then you have a big small sample right there. And so what we have to do with the population proportions, this is what we have to use for P, and we call this as population proportion. We don't know what it is, right? If we know what it is, then we don't need statistics, okay? I mean, we still do, but we call it data analysis. We don't call statistics or data science. I mean, data science is a broader field compared to a statistic by itself. It's include a lot of things, but this is what we call the population proportions. And what we have for a sample, then we can compute the sample size, the p-hat, we call p-hat, which is x over n. Okay, so what is that? So this is the number of success. This is the success. Now we learned from chapter 5, right? So the probability of success is x over the total. So that would be the n. So remember that we never be given by the big N. Some people are asking me, can we compute like the P here? The answer is no, we can't compute the population proportion. I don't even know how many people in the jungle, right? So there's no way that can find out what the true values of the population proportion is. But we can do is we try to estimate it using that sample proportions, right? So let's say how many people supported Trump now? We don't know it. We don't know how many Americans lives in the US. But if we take a small sample and then without bias, and then we run a vote for that. And so if people supported Trump would be around 30%, and then we can use that information to set up the bow for the population proportion. So we have to set up the guard for that part. So the guard going to told you some information about the people who supporting him and people not supporting him in certain matters. So again, the p-hat, which is called population sample proportion. So we need to get used to it, and I think that we deal with that on chapter 7, right? And so a lot of you ask me, why the error bound. So the error is, what is the error bound? The error is basically the difference between the X bar and the mean, correct? And yeah. So, and some of you, if you saw it for like, if you've seen that one before, I divide both sides by sigma over radical n. And this is what we call the z. And I know that most of you learned this strategy before, right? And this is what we call the z. And then do the same thing for that part. And so I multiply both sides by that. And then I can get the error bound equal to the z, e equal to the z times the population standard deviations and over radical n. This is how we came up with the forms for that part. But I think plus and minus, why we have plus and minus, because it was out of the bag for two-tail. So I'm going to tell you what it is on chapter 9. So this is how people came up with the form for that part. So the same thing, that it's wholesome characteristic, so we can compute the mean will be the same thing as the p hat, right? As the p, and so the standard deviation will be the radical of p hat. Is usually p times 1 minus p over n, correct? So this is what we know from chapter 7.
And that's the standard deviation?
That's the standard deviations, right? From chapter 7, I believe. All right? Because of, I'm not sure, should I go back to chapter 7 or no? Or we accept that? Yeah, so we learn from chapter 8, right? So we learn from chapter 7, so we can do like the z equal to the p hat minus p. Does it look very familiar to us?
Yep.
Over the square root of p times 1 minus p, right? I believe that this is the thing that we did on chapter 7, and then we go to the chart and then figure out the answers, right? So the p hat minus p basically equal to the error bound, right? So we want to see how much different between the sample proportion and the population proportion. That will be the error bound. So we want to see what is the error. So of course we always have the error, because sample, even if the sample is a representation of population, but how much representative of that compared to the population that we took. And so this is what we call the error bound. So the most qualified, or I mean the best, the statistician is how they know how to control the error bound really well. We cannot minimize it, but we can control them, okay, based upon how many samples that we do, and also the sampling technique that we do as well. So generally, this is a very, very important question. But anyhow, so this is what we call the mean and this is what we call the standard deviations for the p hat for the sample proportions, and this is the standard deviations for the sample proportion as well. So we learn it. So you can just multiply both sides by radicating of p times 1 minus p over n. We're gonna get the error. So the error bound that we can literally, I can multiply this, I can bring this on here and multiply both sides by radical p times 1 minus p over n. I got the error. So so the error, the e equal to the z times radical of p and 1 minus p over n. So, but the question is, we don't know what the p is, right? If we know what the p, what's the point of doing the estimation for that, right? What the point of doing the estimation? We know this guy. If we know this guy, we're done, right? So what's going on? We don't know the population proportion. So what the statistician they did was they replaced it by the p hat. Okay, this proven. This can be proved. This can be proved using sufficient statistics. We just call theoretical statistics. It's not easy, but it's doable. And so we can prove them, and we can basically replace P by the P hat. It's literally going to give us the same result. Of course, there will be some concern that we have right here, but we're going to accept that. So generally, and after that, we're going to set up the bow. So the bow for the P, basically pretty much the same thing. So that would be the P hat plus and minus the error, which is E. So in other words, I can just do the P hat plus and minus the radical of, the Z times the radical of P hat and 1 minus P hat over N. Okay, so this is the formula that we set up to get the range of the population proportions. Okay, so if you want to say, how many of you who go online shopping, for example, if I want you to see the ratio for all the Americans, consider our class would be the good sample, right? Would be a representation of the populations of the entire United States. So I can use our class information, and I can figure out the P hat, and using that information, I can also set up the bow for the entire proportion. You see how important that is, that we can get a really, really good sample. If we can get a really, really good sample, everything can be done straightforwardly. So for that type of questions. So if we get the wrong sample, that no matter what you do, so the result that we came up with is basically useless. So this is so important. So to stick, the first step always be the hardest and the most important step. It's just like when we learn it. So the basics always be the hardest one to learn. The other thing just trivial. So anyhow, this is all we need to do. And let me just take a look at a few questions right there and see how we can proceed that. Oh yeah, so the example that I took was from South America, and there's a large quake hit the city in South America. It surveyed 2,000 houses and found that 600 of them had collapsed. That's crazy. You see how I'm sorry, this is just a question that I took from the things, but 2,000, you found 600 collapse. What about the other 1,400 houses? Did they get damaged or whatever it is? I don't know. Right, but it was built with a really bad structure. I don't know. So this is what I found from the question. So what we need to do is that we're going to I think I need to move on to the next part. So I need to take this part and just use them. Just do that. And we're gonna change the font to 16 so I can see what it is, right? And so I'm gonna highlight a thing that we need the most, and the thing that we have is 2,000. Oops. Now let me just use slightly 2,000 and out of 600, and we have 95% confidence, right? So we're gonna write them down, and the first step that we need to look for is the P hat. So the P hat is the ratio between people who get collapsed in the house. I'm sorry, it's number of house collapse. So that'd be 600, right? And then we divide it by 2,000. So that we're pretty much done for this part. And that's really important that we do so. So, and after that, we're going to use the calculator 600 over 2,000. So we know the answer is 0.3, but I just want to show you what it is. And so this is 0.3. Okay, and after that, we're gonna set up the bow for the P. Remember that we never know what the true proportions. What is it? Because South America is really big, right? It's include a lot of countries, and of course, there's no way that we can figure out the true proportion, but we can set them up if the survey is unbiased, isn't biased, then we can do that. So we're gonna take the p hat plus and minus z times radical of p hat and 1 minus p hat. Oops, let me just do that here. Let me just rewrite them. So 1 minus p hat over n. Okay. So what we have here would be what? So we have 0.3, right? So the z is the grandparents model. So the z as 95%. So we have a confidence interval. Remember, what is the keyword for chapter 8? Confidence interval. So the confidence interval that we have that we given is 95%, correct? So this is 0.95. And so we're going to take, so 0.95, so 95% of the z-score. So we're going to go to table number 3b that we can figure this out. So the answer for that is 95% is 1.96. Okay, so the answer is 1.96. So the z-score is 1.96. Okay, so after we get the z-score, I'm going to plug that in. So how do we get this value? So we go to table 3b, right? So again, this is the only way that we can figure this out. I mean, this is not the only way that we can figure this out. In fact, it's just the confidence interval. It just says 95%. Some people can get it done relatively easy. So if I show you that one, that would be the thing that we do. So let's say we have the normal distribution calculator. So so let's say we go from 196. So this is 95%. Okay, for the z-score, it's always be negative from negative 1.96 and positive 1.96. So you get this is 95%. So if we learn from chapter 3 is that so the 95% would be approximately 2 standard deviation away, right? So 1 and 2 standard deviation. It's actually approximately 95, but it's slightly less than 95%. I'm sorry, it's slightly more than 95% when it comes to this part. So, and so because z is 1.96, so we're gonna take that 1.96, and then we multiply by the square root of 0.3, right? So we know the fact that this is 0.3 times, so 1 minus p is 0.7. And we divide it by 2,000. Remember that we do not divide it by 600. 600 will be the x, right? The n that we have is 2,000. So we can do that. So 600. The n is 2,000. Make sure that you don't mess them up on the exams. So this is 2,000. Okay. So generally that we have to do just divide it by 2,000. And that's pretty much the thing that we need to do. So the answer for that is we can do that. 1.96 times the square root. Remember, when you do this calculation, you gotta be really careful. And we're gonna take this radical second, the square, and we take 0.3 times 0.7 because 1 minus p is 1 minus 0.3 is 0.7. And then, so we keep doing, right? We have to divide it by 2,000. Okay, so now after that, we close the parentheses. We have to close the parentheses in this case. I mean, sometimes we don't have to just give you the same answers. So we get the answers 0.02. So what we have to do, I'm going to rewrite this. Let me just write it down in terms of the whole thing. This is 0.3. Let me just make this a little bigger. Okay. So what we need to do, that means that we become, so the entire things become 0.3, right? Plus and minus 0.02. And that's pretty much it. Okay. So plus and minus. So when we take 0.3, oops, minus 0.02, we get 0.28, and 0.3 plus 0.02. No, yep. So we got 0.32. So the final answers that we get would be 0.28 and 0.32. So what does this tell you? I can tell you that on average, that the proportion of all the collapse houses in South America would be around 20% to 32%. I can't claim that it is maybe 27. I can definitely tell you that it is not 27%, but I can tell you that between 28 and 32%, what is that real value? So this is the bound that we have for the true proportion. Remember that the p should be between 0.28 and 0.32, right? This is all we can tell, but you can say what is the exact value for that part. It's very important. Okay, so that's pretty much the things that we have. And now we're going to deal with some example. I'm not sure if I give out some example for that. I feel like just give one example. Okay, so let's do. So let me just practice some questions. I believe some homework questions, and let me do it for spring. So that'll be chapter 8, homework problem. And so this is the thing that we're going to do with. So let me just try to do a few examples and see how that's going to help us. Okay. And so this is estimation. This is we just did the t. This is also for t. Let me try it out with the, with that one. So what we have here will be the students. The student interviewing at the major company wants to know his chances of getting a job offer, and his survey 18 alumni that had interviewed with the company and felt 9 of them had received a job offer, and you want to construct a 90% confidence interval for the population proportions. And so this is pretty much the same question. Let me just do it right here. Okay, so we pretty much do the same thing. I'm going to make it a little bigger so you can see them. So this is homework 16, homework problem 16. So we're going to do that 16. And so all we need to do is, again, that we're going to figure out the p-hat. The p-hat will be the first thing that we need to do. So the p-hat would be equal to x over n, right? So we're going to highlight them. What is the x? So the x equal to 9. 9 of them had received a job offer. You need to look for that. You can't just see. And then the n equal to 18. So this is the n. Let me draw a line real quick so that we don't want to mess up with the entire questions. And so this is the n. And this is the x. Okay. And now we have the p-hat equal to x over n. So that would be 9 over 18. So 9 over 18. And so the answer that we can compute it, which is 1/2, right? And it's 0.5. But since the sample is really small, that'll be 18. Usually we cannot do so unless the question state that this is a normal distribution, because 18 is too small. So anyhow, so the CI, if this is the normal curve, then it's good. So the CI that we have is 0.9, which is 90%, right? So all we need to do is that we're going to set up the P, which is equal to the p-hat plus and minus z times the standard deviations, which is the p hat, and 1 minus p hat over n, okay? So this one will be equal to 0.5 plus and minus. So now we have to look at the z-score. So the z-score of 90% confidence, I can say that this is 1.645 from table number 3b, right? So the z is 1.645 of table 3b. Okay, so why is that? So we can just take a look at that. So 90% is 1.645. And after we get this done, so we're going to rewrite the entire thing. So we're going to take 1.645. And then we multiply by the p hat. So the p hat is 0.5. So we know the fact that 1 minus p hat, so 1 minus p is 1 minus 0.5, also 0.5. And we divide it by n. So the radical, we divide it by n in this case will be 18. So we're going to do it on a calculator. So we're going to take 0.5 plus and minus. So we're going to take 1.645 multiply by the square root of 0.5 times 0.5 and divided by 18, and we close parentheses, and then we got the answer is 0.19, right? 0.194 or 0.19. Okay, so and then we settle the bound for the population proportions. We're gonna take 0.5 minus 0.19. In this case, we're gonna get 0.31. And then similarly, we take 0.5 plus 0.19, and we got the answers, which is 0.69 as well. Okay, so that's pretty much a thing that we have to deal with the population proportion. So it's basically we set up the same problem again, that we take the p hat plus and minus z times the radical of p times p hat 1 minus p hat over n, and do it over and over again for that part. So finally, that we're gonna go to one more things. So we set up the error bound. So this is pretty much the trade-off. So we gotta be really careful for that part. So why it is so important to know how many samples we should collect. So collecting a representative data set sample for the population sometimes is very hard and they're very costly. And then we haven't really tested how important that is to collect a small sample, right, from a big population. So it's not an easy task to make our sample unbiased from the population. So in other words, it's more like a trade-off between band cell. It's a trade-off between the acceptable error bound and the n. So people usually have to balance out with that. If we collect more sample, meaning that we need to we're going to have a better estimation. If we collect less sample, meaning that you have a big error bound, meaning that the estimation will be worse. So in other words, collecting the sample collecting more sample going to reduce the error bound. So there's no way that we can reduce the standard deviations, and there's no way that we can reduce the z or the t score, because all of that is intrinsic value of that of the data set. So what's going on for this is so let me just rewrite them. So the e that we found would be equal to the z times the standard deviations over radical n. Okay, So, or which one that we have to use? Either the first or the second. So we cannot use the second one because of the fact that because the t basically depends on the degree of freedom. Remember, the z only depends on the confidence interval, but for the t-score, it depends on the degree of freedom, which is and the confidence interval for both of them. Right, when you look at the chart, right? So when you look at the chart for table number 4, you can see that the degree of freedom going to gives us different value for the t. So in other words, there's no way that we can literally solve for n using the t distributions. Okay, so we cannot use the this formula for that part. So in other words, we need to solve for n using the z, using the population standard deviation formulas. So so what we need to do is that we multiply both sides by radical n, right? You can literally check. This is what we usually have to do. And we cross them out, and then we divide both sides by e, by the error. And so we cross them out, and then we can solve for the radical nth, which is equal to the z times the standard deviations over error. So, so what is so important to know? Because before we start any research, before we start any statistics, okay, we want to know how many sample that we that we should collect. But how do we know it? So we want to see how much error that we can bear with during the study. So so we square them in order to get rid of the square root, and we can have the n in this case will be equal to the z times the standard deviations over e square. It is a very important statistics. It is really, really important. Okay, so similarly for the proportion, we basically do the same thing. For the proportions, we have the error barrel for the proportion. So this is for the quantitative data set, quantitative data sets. This is for quantitative data set. Okay, so for the quantitative ones, so that should be a little different. So for the qualitative data sets, so what's going on? When you look at the error bell, so the error that we just learned from the proportions, so we know that the error bell is here. So the error will be the z times radicand of p hat and 1 minus p hat over n. Okay. So what's going on for that part? I need to solve for n. So we need to do some manipulation, pretty much same thing for that part. And then we can get them the n equal to the z over error square. Okay, over the error square. And after that we multiply by we don't do the square root, right? Okay, so we square both sides, and then we multiply by the p hat and 1 minus p hat. Okay, so let's say I don't know how many people supported Trump, for example, or maybe take my example. How many like me? How many of you who like me generally? So so if we don't know the p hat, for example, because we haven't done any research before, so what should we do? We going to take the p hat equal to 0.5. Okay, so let me just just put down the quick note. If the p hat is unknown, okay, so meaning that there's no prior estimators. I might give this question on the exam. So meaning that we're gonna take p hat equal to 0.5. Okay, so very important for that part, and then we can read some example, and then we solve for that. So that would be the continual lectures on next Tuesday. Okay, so I know you guys are really tired, and I'm also really tired too. And just call it a day. Any other questions? Now we're gonna take attendance, correct? Again, those are the notes that we should pay attention, and then we're gonna practice this part, and then after that, we're gonna quickly move to chapter 9. Remember, we still have how many chapters we had to finish? We have to finish chapter 9, a little bit on chapter 10, 11, 12, 14, and 15. So all of these chapters should be something that we keep in mind. Okay.
Wait,
So-
Professor, can you go back to the quantitative and qualitative?
Yeah.
Oh.
So let's say you want to test on how many people who supported Trump, right? So if we haven't really picked a sample, what should we do? So let's say I'm going to pick the p hat would be 0.5, for example. I don't know who should be unbiased, so I take 0.5, and then I can pick the error bell. I don't want the error bell should be more than 10%, so I pick the error equal to 0.1, and I can use the confidence interval. I would say 90% or 95%, depending on the purpose of the study. If you want to be very uncertain, you want to be very certain, you can pick the big confidence interval. If you have a big confidence interval, meaning that you're going to pick a big sample. And so then we can compute how many samples should we collect in order to satisfy all the requirement that we have. Okay, so this is the thing. Anyhow, so we finish all of this, and let me just take attendance real quick before we call it a day. And this is pretty much what we need to do. Okay, so for chapter 8, it's sort of a little bit longer than what we expected, but it's generally the thing that we need to do. Okay, so now let me just pick on a person. I'm kidding. Okay, so let me just do that. So I would ask you, how much do you like the online learning, like the remote learning? Do you like that, or do you not like that?
For this class, I like it because you record your lectures, so I can actually like go back if I don't understand how I took my notes or something like that.
Uh-huh. What about the other classes that you're taking? They don't.
For me, it also depends for like for this class, it's fine. For other classes, it's just a little bit more difficult.
Yeah, this is actually a very challenging course that we need to take, and to be honest. Okay, so let me just see.
Accounting online should be a crime.
Yes, I agree with Olivia.
For accounting,
Yeah,
which one?
managerial.
Managerial accounting. That's
I took financial online.
okay.
Financial line wouldn't have been that hard.
All right. It's really interesting to know that you guys love to take accounting courses. Yeah. So let me just see who here and so not here. We have 33 members, meaning that we have missing 3 of them. I believe that we missing Anthony, right? Anthony. I'm kidding. I'm kidding. I saw your name on the top. I just want to see if you have some reactions for the class. Maybe you slipping around. I can't pick on you. I don't even see you for that reason. But so that would be embarrassing when people turn on the game and then you attend a lecture and sleeping around. That's not fun. So let me just check. Definitely we don't have Danner. Do you know who can contact Danner? Danner Jerson. Anyone knows in this classroom? Anyone knows?
I don't think I've ever seen that person in class.
Oh, I've never seen that person.
Okay, yeah. So I tried to email her. I got no response. She put me on ignore. I'm happy with that though, because I hate all of you guys in this class. Anyhow, Elias here.
But she's gonna pass the class, right?
She's not gonna pass for sure, 100%. anyone who never come to the class will never have a chance to pass to be complete. There was a girl last semester. She gave me a lot of trouble saying she took the third exam, she failed it, and she got 59 out of 100, and she didn't take the second I think she took a second exam, also failed the second exam, and when she took the final, she also failed the final, but she gave me a lot of trouble with the makeup exam, or I mean the defer examination. I mean, she still failed because it's really hard to pass a person when she never come to the class and never did any work for this. And I feel like that's pretty good. And everybody showed up. That's wonderful. And then I hope you guys enjoy your weekend. Stay home, stay safe, enjoy a wonderful life. It's look like we are being kept in prison anyway. So, and for
Yeah, I
those of
heard
you,
May 15th.
yeah, so May 15th. Yeah, so for those of you who again who missed so many questions, you need to email me. Okay, you need to email me, and we're gonna set up maybe. I'm not sure about your personal issue or technical issue. You have to tell me why you're missing so many questions. Maybe you have no idea how to solve them, or maybe because of the internet connections, or maybe you have to take care of your family members. So all of that take into account, and let me know, and I will going to respond back to you as soon as possible. Okay, so you guys have a wonderful night.
Goodbye.
Bye.
Thank
Bye.
you.
Thank you.